All right, guys, so what we're doing is chapter 1.3. We're talking still about transformations, but mainly we're going to be talking about absolute value and some different transformations with absolute value. Now, the first thing we have is horizontal and vertical translation. Now, horizontal translation, as we talked about already, is moving it to the left or to the right. Now, whenever it's inside the parentheses, it's always kind of going backwards or opposite of what we think. So here the graph y equals f of x minus h is given as a horizontal translation. So if it's moving it to the right, the h value is positive, but it's going to look like it's negative. Because if we move it 2 units to the right, it's going to be put in as kind of x minus 2. Now if we move it 2 units to the left, it's going to be x plus 2. So it's a little bit opposite of what we think, and we're going to do it inside the parentheses, which is going to be a little bit different, but we'll see it, and it'll make sense when we do some examples. Now the other type is vertical translation. That means we're moving up or down. Now y'all like vertical translation a lot better than horizontal translation because it's more straightforward. But we're just going to take our function and we can add 2 to move it 2 units up, or we can subtract 2 to move it 2 units down. It's moving it up and down. And that's all it is. Horizontal translation is left and right. Vertical translation is up and down. And we're going to be working with functions like this one here. So our first example, let f of x equal 2x plus 1. Write a function g whose graph is 3-unit translation down of f. So I'm going to say g of x, our new function. This is just our new function. And what we're doing is we're taking the function f of x and translating it 3 units down. Now, translation of 3 units up and down is dealing with outside the function. We'd be subtracting on the outside. So we do f of x minus 3. Now, what is our function f of x? Our function f of x is 2x plus 1. So this here is 2x plus 1. So I'll write it in, 2x plus 1 minus 3. So we're going to subtract 3. Now, we won't subtract 3 from 2x because they're not like terms. We're going to do 1 minus 3. And 1 minus 3 is negative 2. And that's it. Our answer is that right there. So 2x minus 2 is a translation of 3 units down of our original function. And that's all we have to do for this here. That's it. Now let's look at this next one here. Write a function h whose graph is a translation of 2 units to the left. Now remember, left and right is inside the parentheses. So our h of x is going to equal f of x, what? Because it's moving to the left, it would be plus 2. If it was to the right, it would be minus 2. We have this here. Now our function is 2x plus 1, but we don't have x anymore. F of x equals 2x plus 1. We don't have x anymore. We have what? X plus 2. So anywhere there's an x, so right here, we're going to replace it for this one here with x plus 2. So we have this 2 parentheses. We don't have an x anymore. We have x plus 2, and then we have plus 1. So we've replaced x with x plus 2 because we're moving it 2 units to the left. Now what we need to do is we need to simplify it. So we will distribute our 2 throughout. So 2 times x gives us 2x. 2 times 2 is 4 plus 1. Combine like terms. 4 plus 1 is 5. So our new function that is moved 2 units to the left is this right here. This is our new function. And that's all we have to do for this one here. Yes, we'll look at another one. Let's look at another one. So this here, they told us the function f of x is 4x minus 9. We want to write a function g whose graph is a translation of 5 units up of the graph f. 5 units up. So that means our g of x is going to be equal to the function f of x, and we're moving it 5 units up, so we're going to add 5 to the function. We're going to move it up 5. We're adding 5 to it. So our function f of x, which really hasn't changed, it's still this right here, because we're not doing anything inside the parentheses. So we can just go on and replace it with 4x minus 9. Now at this point here, we can just combine like terms. 4x doesn't have any other terms with it, but the negative 9 plus 5, negative 9 plus 5 gives us negative 4. So our new function g of x is 4x minus 4. And that's it. That's all we have to do for this one here. Now let's look at the next one here. Write a function h whose graph is a translation 1 unit up, or sorry, not 1 unit up, 1 unit to the right of the graph of f. So h of x. So if we're talking 1 unit to the right, that means inside our f of x, we're going to have 1. But because it's to the right, we don't do plus. We don't have a plus sign. We have a minus because, again, it's kind of opposite of what we think. It's opposite what we think about. So instead of having plus 1, we have minus 1 because we're moving to the right. Now, just as a reminder, our function f of x, I'll write it over here, is equal to 4x minus 9. Now, again, we don't have x anymore. We have x minus 1. So here in x, we're going to replace it with this x minus 1 when we rewrite this out. So we'd have 4 parentheses x minus 1 minus 9. Now to simplify this out, we have to distribute the 4. We have to multiply through by 4. So 4 times x is 4x. 4 times negative 1 is negative 4 minus 9. Well, negative 4 minus 9 is negative 13. So our new function h of x is 4x minus 13. That is our new function for this here when we move it 1 unit to the right. We move it 1 unit to the right. And that's all we have to do for this here. That's all we're doing for this one. So we're going to do some more of these here. So this one here, we're given the function f of x equals 3x, and we want to translate it 5 units up. And if we're translating it 5 units up, it means we're taking the function f of x and adding 5 to it. Because when we move up and down, we're just adding it to the function or subtracting it from the function if we're moving down. So we're adding it to it. Well, f of x is what? It's just 3x. 3x plus 5. Bum, bum, we're done. We are done with that one there. That one's a little bit simpler. Moving it up and down is pretty simple. It's not too bad. Now the other one here, so we're moving to the right. So this one's a little bit trickier because, again, moving left and right is a little bit harder than moving a function up and down. So we'd have x and 4. Now again, so it's moving it to the right. We want it, again, right, negative, because if we're moving it to the right, it is negative. So we'll have x minus 4 because we're moving it to the right. It's opposite of what we think. Now all we need to find is the function. So inside we don't have f of x anymore. We have x minus 4. So we're going to replace this x with x minus 4. And when we do that, we have the absolute value of x minus 4 minus 3. And that's it. That's all we have to do to translate this 4 units to the right. And so that's it. That's it there with moving it up, down, left, and right. That's all we have to do to rewrite these using our transformations of horizontal and vertical shifts. Now the next thing we have is reflections. Reflections in the x-axis and reflections in the y-axis. Now when we have a reflection in the x-axis, we're making the whole function negative, negative f of x. We're applying that negative throughout the entire function. Now, so just like this here. Now, one of this, and we'll see an example of how this looks, but it applies to the whole thing. We're just doing negative f of x. We're applying it to everything in the function. Now, when we reflect it in the y, we're only applying it to the x. Any spot there's an x in the function will get that negative. So it's a little bit different. It's not affecting everything. It's only affecting some parts. So that might sound a little confusing. So let's look at some examples of this here. Write a function g whose graph is a reflection in the x-axis of the graph. So like we just said, when we reflect in the x-axis, we're applying it to the whole function. So if I want to reflect this in the x-axis, what we're saying is our new function is equal to negative f of x. We're going to apply it to everything. Now what is f of x? F of x is the absolute value of x plus 3 plus 1. So what we're saying is we have negative absolute value of x plus 3 plus 1. We're applying the negative to everything. Now, it won't go inside the absolute value, but we're going to multiply it by the absolute value because we're essentially multiplying this all by negative 1. So if I multiply the absolute value by negative 1, I get negative absolute value of x plus 3 then I've got to multiply it by the 1, and positive 1 times negative 1 gives me negative 1. And that's it. That's all we have to do for this here. That's the only thing we have to do. And we have our new function. Now, h of x, so I'm going to rewrite f of x. F of x equals the absolute value of x plus 3 minus 1. Write a function h of x whose graph is a reflection in the y-axis of the graph f. Now, for reflections in the y-axis, what we're going to do is we're going to apply it to what's inside. We're applying it to what's inside f of x. So for here, we're saying h of x is equal to f of negative x. So any place there's an x in the function f of x, we're going to replace it with negative x. We're going to replace it with negative x. So here, when we replace it with negative x, there's only one spot. It's right here. So this x is now going to be negative x plus 3. Make sure I copy that right. Plus 1, not minus 1. Plus 1. So we have plus 1. Plus 1. And that's it. Now, the textbook is going to say that what we can do is we can factor that negative out and rewrite it so that this x value here is positive, which is fine. And we can say negative 1 times x minus 3. Because when we factor that negative out, and then we get simplified down. But we're not going to worry about that. I will take this right here as your answer. That is fine with me. This is fine. I will take this as your answer. Because this is a reflection in the y-axis of this graph here. And that's all we have to do for this here. So let's look at this one here. Let f of x be this function here, the absolute value of x minus 5 minus 4. Write a function whose graph is a reflection in the x-axis of the graph of f. So if we're doing a reflection in the x-axis, we're doing f, negative f of x. We're applying it across everything. So our function, I'm going to do parentheses, is our absolute value of x minus 5 minus 4. It's the whole thing. So when we apply that negative, we're going to multiply, essentially multiplying by negative 1. We're going to multiply these both by negative 1. Not what's inside the absolute value, just the absolute value. And when we multiply the absolute value by negative 1, we get negative absolute value of x minus 5. Negative 1 times negative 4 gives us plus 4. So this right here, our new function, is a reflection in the x-axis of, or across the x-axis of this graph here. And that's all we have to do. That's it. Now let's look at this next one here. This one here, we want to write a function of g whose graph is a reflection in the y-axis of the graph f. So again, when we do a reflection in the y-axis, we're inside the parentheses. We're changing all the values of x with negative x. We're changing all the values of x with negative x. So that means here in our function, this x, we're going to replace with negative x. So when we do that, we'll have the absolute value of negative x minus 5 minus 4. And we have this here, and that's it. That's our graph. Now, again, like I said earlier, there's ways that we can manipulate it and get the negative out, or factor the negative out and simplify it down. But I'm going to leave it as this here. I'm going to leave it at this here. And again, if the homework counts it wrong, just let me know. I will correct it. I will give you the credit for it. Because this is the correct answer. The book might say it's this here. But there's no difference in the graph of these two here. They're the same thing. These two here are the same thing. And that's it for that one there. So we're going to do one more of each. So here, reflection in the x-axis. So again, when we reflect it in the x-axis, we're making everything. So we're doing negative f of x. We're applying a negative to the entire function. The entire function. So when we apply it to the entire function, really what we're saying is negative parentheses. And then we have our function negative absolute value of x plus 2 minus 1. So I'm multiplying essentially everything by negative 1. Well, negative 1 times this negative is going to make it positive. So we have plus the absolute value of x plus 2. And negative 1 times negative 1 is plus 1. So our reflection in the x-axis for this graph here, or for this function here, f of x, is the absolute value of x plus 2 plus 1. And that's all we need to do for this here. Last one here, we're going to do a reflection in the y-axis of 1/2 x plus 1. So again, our reflection in the y-axis is we're taking negative x, f of negative x. So we're going through the function and replacing any x spot with negative x. We're replacing it with negative x. So what that'll give us is 1/2. Well, I don't have x anymore. I have negative x plus 1. Well, we need to simplify this here. 1/2 times negative x, well, that's just negative 1/2 x plus 1, and that's our function. And that's all we have to do for this here. That's it. That's it. That's all we have to do. That's all we have to do for this here. And we are done with that. Now, this brings us to the last part. This is the last part of this here that we're going to look at. Horizontal stretch and shrink and vertical stretch and shrink. Now, I'm going to talk about horizontal stretch and shrink. Horizontal stretch and shrink. A horizontal stretch means it's increasing faster along the y, or along the x. It means it's expanding more. I am doing an expanding motion, and I've realized that none of y'all can see this because this is a video, and you're not actually here. So, I digress. So when it expands faster, it's moving faster along the x-axis, along left and right. It's moving faster that way. A horizontal shrink means it's moving slower. It's increasing faster along the y. But we're not going to focus too much on horizontal stretch because there's a lot of stuff in it that's really complicated and really confusing to try to keep straight. So I don't really talk about horizontal stretch and shrink too much. But what we will talk about is vertical stretch and shrink. So if it's a vertical stretch, the value of a is greater than 1. A stretch, the value of a is greater than 1. We talked about this. And it's a shrink if 0 is less than a is less than 1, if it's a fraction. Now also look at this here. It's kind of cool, magic pen. Let's look at this part right here. That part right there. It's a little blurred, but we have a times f of x. And what that's trying to show you, what I'm trying to show you with that there, is that, if I can get it to go away now. There we go. Is that we're going to multiply it by f of x. And it doesn't matter if it's stretch or shrink. We're multiplying the whole thing by that value. Whole thing by whatever the value of the stretch or shrink is. And that's it. That's how we apply the stretch or shrink. So this here, if we want to apply a vertical stretch of 2, a function h whose graph is a vertical stretch of the graph by a factor of 2, our value of a is 2. And again, when we apply this here, we do a times f of x. Well, in our case, our a is 2 times our function. Well, what is our function? This whole thing right here, the absolute value of x minus 3 minus 5. So to apply this here, we're going to multiply through. We're going to multiply both of these here. Now again, the 2 doesn't multiply inside the absolute value. It's just going to be 2 absolute value of x minus 3. 2 times negative 5 is negative 10. And that's it. That's our vertical stretch of 2. Our vertical stretch by a factor of 2. That's it. That's all we have to do for this here. This one here, we want to write a graph whose function g, whose graph is a vertical shrink of the graph of x by a factor of 1/3. And again, 1/3, that is less than 1 and greater than 0. So it's a fraction. So it is a shrink, a vertical shrink by a factor of 1/3. So what we're going to do, so g of x, I'm going to write it out, is equal to our 1/3 times f of x. Kind of like just with the last one, we're multiplying the whole thing by 1/3. Because when we do vertical stretch or shrink, we multiply the whole function by it. Now our function is the absolute value of x minus 3 minus 5. So I'm going to multiply both of these here by 1/3. Now, when we multiply the absolute value, well, the 1/3 does not go inside the absolute value bar. So it's just 1/3 times the absolute value of x minus 3. Now, 1/3 times 5, well, that's just 5/3. So our new function with a vertical shrink of 1/3 is this right here. That's all we have to do for this one here. We just multiplied it by 1/3, and we got 1/3 the absolute value of x minus 3 minus 5/3. And we're done. That's it. So we're looking at another one here. We have a vertical stretch of the graph by a factor of 5. So again, a vertical stretch. What we're doing is we're multiplying the function f of x by 5. So we're doing 5f of x. We're increasing everything by a factor of 5. Well, what is f of x? F of x is the absolute value of x minus 1 plus 2. So we're multiplying everything by 5, the absolute value by 5 and 2 by 5. So we're not multiplying x minus 1 by 5. We're not what's inside the absolute value. We're just multiplying the absolute value. So I have 5, absolute value of x minus 1 plus 5 times 2 is 10. And that's it. That's our function. That's our new function there. And that's all we have to do with this here. When we do a vertical stretch or shrink, we're multiplying the entire function by that value. So last one here, vertical shrink, not shrink. Vertical shrink. And what we do again, just like with vertical stretch, is we're going to multiply this entire function by 0.25. So we're going to have 0.25 times f of x. Well, our f of x is the absolute value of x plus 1 plus 2. So we're going to multiply both of these by 0.25. Now, we won't multiply what's inside the absolute value by 0.25. We're just multiplying the absolute value by 0.25. So at 0.25 times x plus 1 plus 0.25 times 2 gives us 0.5. And that right there is our function. That is our function with a vertical vertical shrink by a factor of 0.25. And that's all we have to do for this here. All right, guys, so we learned all the stuff we're going to use so far. We're not doing anything different, but we're combining them. So we're going to do some combining these different transformations. So when we combine some of these transformations, it's just putting them together. Now, what I want you to do, so I'm going to wrap this up. It's going to be short. I want you to try this here on your own. I want you to try combining these transformations. So first, what you're going to do is I'm going to talk you through, you're going to do the vertical shrink by a factor of 0.25. Once you finish doing the vertical shrink by a factor of 0.25, you're going to do the translation of 3 units up. You're going to do them one at a time, and you will get the rule for it. So go on and pause this video at this point here and work this through. So hopefully at this point you paused it. Hopefully you paused it and you just didn't let it play, but you paused it and worked this out. So if you work this out and did the vertical shrink of 0.25 followed by a translation of 3 units up, you will get that the new function f of x is equal to 0.25x plus 3. And if not, we're going to work this through on Monday and see how this works.